All right, this is part 2 of chapter 6, networking layer. So I said routers, as you can see, all right, routers routers do learn about other routes by from directly connected routers, right, in this case, or from remote routers, other routers that they're not directly connected to, right? All right. So IPv4 routing table. Once a router have learned about routes, if you go to a Cisco router and type, if you want to see the routing table, you type show IP route over here. And in this routing table, you can see here the router is telling you what route does it know, right? And what path will it use to forward packet, and how did it know about this route? The CNL, I'll start with the CNL. If you're looking at the CNL, this is our locally directly connected. So the router is telling you, I can reach 192.168.10 and 192.168.11, and also 192.168.11, what do you call it, and 209.165, 209, 165, 200, because I am directly connected to them. I can reach them by using my gigabit Ethernet, right? Now, if you look at the D, the router is telling you I can reach network 10111 by using not because I'm directly connected, by using my serial interface, and I learned about this route using dynamic routing protocols, right? And I truly think, I think 90 I think is OSPF. I can use OSPF protocol I have learned about this route dynamically using OSPF. Before I move on, so if you type show IP route, you can see all the routing table like in a GPS or any map, and the router is telling you about the route that it can reach, how long, how fast, how quickly it can reach them, when did it learn about them, and how they learn about them, right? In the following example, you can see, like I explained before, you can see that this router here, right, CLL, said this router is telling other router, I can reach this network because network 192.168.10 network, because I am really directly connected to it, and it's talking about this side of the network. I can reach this because I am directly connected to it, and I can get to it by using my gigabit interface right here, 00. All right. So C, identify that the network is directly connected. L, identify that it is local to itself, meaning it's directly physically connected to it. In the following, it shows you here, it is not directly connected. It's one hop away. So for instance, you can see here, for example, router 1, the router 1 in the figure to the left receives a packet that needs to go where? It needs to go to this network. It's destined to 10.1.1 network. So routers have used its routing protocol, OSPF, and dynamically learned how to route this packets that is coming from here, how to route it over here, all right? How to route it over here. And it tells us the time, it tells us the administrative distances, and how much it will take, and what is the next hop. I mean, it said next hop mean I am going to take this request and send it using this exit right here, S000. All right, water. Now we're going to move on to the router. So now we're going to move to the physical routers, look at the inside routers, and see what a router are made of, and what do you call it. To be honest with you, if you ever open a router and you look inside of it, it is really very similar to computers. Really, really very similar to computers. The most common component in the router, and every single, this is RAM, memory in a router. You need to know all what the router does, all the routing process happen in RAM, some type of RAM. So a router has RAM, random access memory, right? 256 or 512, all right? And a router uses RAM to host the operating system. By the way, the operating system running, all right, is hosted on some of the functions that are hosted or stored in a routing in a RAM, ARP table, routing files, and packet buffer. When packet are buffered, they usually are stored in the RAM. A router also have another type, by the way, RAM, it's volatile, and mean if you turn off the router, whatever information of it that is here, it will dissipate, it will disappear. Router also have another type of RAM known as NVRAM, and NVRAM stand for non-volatile RAM. And some of the information that the router stores in NVRAM, it's a startup configuration. Startup configuration. In anything that is stored in NVRAM, even though if you save the configuration, you turn off the router, you're going to lose whatever's in RAM, but you are not going to lose what's in NVRAM. Next type of RAM, routers also have, you guys can think of it for computer as a BIOS if you want. The next type of what do you call it, known as a flash RAM. In flash RAM, which is also example like a BIOS if you want, for PC. In the flash RAM, the router stored the operating system file. So the operating system, Cisco iOS, lives in the flash RAM. And finally, ROM, read-only memory. In read-only memory, routers stores the post, which is a post on self-test. It's a small program that a router runs every time when it boots up to test and make sure that everything is working. Again, it's very similar to what if you ever open up a computer. This three type of RAM, if you want, are similar to what PC use, but the function is really different, right? Inside, if you open up the case and you look inside the router, like I said, it's really similar to a PC. As a matter of fact, I remember the old routers. They were as big as a PC. When you look at them, they look really like a desktops. Inside the router, we'll find a power supply. It's right here. You'll find a cooling fan, and it's right here. You find an SDRAM. I may be able to see it, I may not be able to see it, depend on what you call it. I think it's right here, the SDRAM, all right? You find NVRAMs, all right? You find CPU. Sometimes I may be able to see it, I may not be. I think CPU is right here. You find a heat shield, which is protect against heat, and it's on top of the CPU. And you can find a lot what we call integrated module, IC, integrated circuit, that would not be very easy to really identify. But some major component in the routers are really similar what you may find in a modern computers. Now, on the back of the router, on the back of a modern router, you can find couple. This is northern record. You find, for instance, you find an enhanced or just a wide area network. What do you call it? For instance, right here you can find a couple interfaces like EHWIC, which is used for a wide area network, right? Connected router to another router, connected router to other devices. You find a console port. It's very hard for me to see. Console ports not labeled, but usually by color you'll be able to see the console port. You find an auxiliary port that is used for to connect a modem. You may find a USB. In this case, there's a USB over here. You find a gigabit Ethernet, and it's right here. There's a gigabit Ethernet. In addition, compact flash, which is right here. Right here, we add it. And USB, I just mentioned the USBs, right? So this is the back of the route. It's really very important. And of course, the switch and the power. It's very important to know the back of the router because when you need to connect cables, all right, so you need to know where to connect it. And you have to be able to identify all the ports at the back of the router and what kind of devices will be connected to those ports. All right. Now, if you need to know what version of operating system a Cisco router run, just type show versions. If we type show version, it tells you Cisco iOS, and in this case, it says version 15 right here, version 15, and what release is it. This is the lab that we're going to do together. I'll do a little demo. Now we're going to move into if you inherited or you have a new router, what are the basic what do you call it, a router and switch configuration. And this is what I'm going to do as a lab with you. This is what we call enable config T. So all this command are their basic requirement for any given routers and for any given switch too. A great deal of command and a setting that a router requires, a switch will require too, with certain differences, of course. And when we configure a router like we did before, a router has a different mode, and a different mode they can do different things. For there is secure. So the thing that we do, secure the exit mode by using enable and set up a password. Secure telnet and SSH by assigning a username and a password to the VTY and SSH. Secure the privilege admin mode. So anybody try to configure the router, they'll be asked for a password. Provide legal notarization, or what we call MOTD, message of the day. So this is, we're going to do it together as a lab today. This is another lab. This is a lab I'm going to assign you for assignments. All right. Configuring router interfaces. A router does have interfaces, unlike switches. Router has physical interfaces that you need to bring and assign an IP address and also subnet mask, and give it this command, this funny command, no shutdown. You type no shutdown to bring the interface up. If you don't do this, although you assign the IP addresses and the required setting, the interface may be down. The interface will remain down. In here, show IP interface brief. If you want to see if you properly configured the IP addresses and the interfaces, a command says show, and it's right here, show IP interface will show you the interfaces, and I'll show you. You can see here this interface is configured, yes, has an IP address, yes, and is it manually by network administrators, and it's up and up. If it's not properly configured, it's going to be down. Now let's pretend you gave it the IP addresses, you gave it a subnet mask, but you forget no shutdown command. So you're going to see that it is up, but the protocol is down. All right. Other command that we use, we can do show IP route to learn about all the routing, all the route that the traffic learns about. We show IP interface by seeing all the interface. And finally, once you're done, once you spend time configuring the router, do never forget to type the command, copy the running configuration to startup configuration. If you forget to do this and you turned off your routers and you turn it back on, all your configuration will be disappeared. The router will not save anything. Now the gateway. We started talking earlier about the gateway, and I told you the gateway is very important, play a crucial role for for all end devices inside the network. I'm gonna tell you this one. In the absence of a default gateway, which is the IP address of a router, none of these devices will be able to reach the outside world. All right. Now you understand this very clearly. Then you may say, so why do we have to assign a default gateway to a switch? The reason why you want to assign an IP address, a default gateway to the switch, in case you're not in this network, not in the same network with the switch, not the same physical location, you are outside and you want to, from using SSH from remote location, be able to configure this switch. The only way to be able to do that if the switch has a default gateway. So I did talk about the default gateway for the switch. If you want to configure for remote, it's very crucial. And here's a good example. So for this case, you say the user is here and the switch you want to configure, it's over here. So you can't physically physically connected to it, and you can't SSH to it because not in your network. The only way to reach this switch, you have to make sure to configure the default gateway. And the command to do that, it's IP default gateway for the switch. All right, so we are done with this chapter, chapter 6, networking. And here is quickly, there's a lab, we're going to talk building a switch network. I want to take you to the end of, what do you call it? Quickly what we did. All right, so quickly what we did, we talked about I introduced you to the function of the network layer, and I told you it's layer number 3. I also told you its job, routing traffic, and also encapsulate and de-encapsulates. And I told you the most common, it's layer 3, and the most common two protocols that work at layer 3 is IPv4 and IPv6. And I also explained that both IPv6 and IPv4 are logical numbers used to identify node and devices in the network. And I said it's really very similar to your phone number. Your phone without an ID, without a phone number, will not function. And I said we have two types of IP addresses. We have different type of IP addresses. We have something known as a public IP addresses, and that's what any node or any machine on the internet uses a public IP address, which is you have to pay money for. And we also have a private IP addresses, which are the IP addresses that we use inside the LAN in our network. And I told you that IPv4, it's 2 to the power of 32, which is about 4 billion IP addresses. And I reminded you that we have depleted all the IPv4, and now we're moving to IPv6. Unlike IPv4, IPv6, it's 2 to the power of 146. 128. So as a result, it's about 340 decillions IP addresses, a number that we can assign to. All right, so there is more is going to come. This is really one of the most interesting chapter in the book, if you want, in the course, if you want. Now I'm going to stop part 2 of the lecture, and I'm going to move on to the lab demo.